Hi again, pre-calculus students. We're starting our next to last unit of the whole course. This is chapter 10. Primarily it's going to be on conic sections, but this first lesson is called Intro to Analytic Geometry. That may seem to be kind of a foreign word to you, but what we mean by analytic geometry, as you can see, and a key thing right here is coordinates, as we'll see, and sometimes theorems, formulas to reason out a conclusion about something. Here's about 4 key things that we'll use on these. The distance formula, which you remember to be this. This is if you are given a couple points, x1, y1, x2, y2. It's kind of a variation of the Pythagorean theorem, basically. Facts about parallel and perpendicular lines. You know that parallel lines have to have the same slope, and perpendicular lines have negative reciprocal slopes, that type of thing. Here's a midpoint formula. Add the x's, divide by 2, add the y's, divide by 2, and various properties of polygons. We'll actually be trying to prove some of these properties, mainly by using coordinates and a couple of these other ideas. We'll see how that works in a little bit. Alright, so here we go. We're just going to go right into some examples here. First one, if they give you these 2 points, could you find the distance between them and also the midpoint? Okay, so first of all, let's see if we can find the distance. I'll just call this d, and that is the square root of the difference of the x's. I kind of like to just do this in my head. How far is it from 2 to negative 4? Well, maybe I'll write it out just so you can kind of see. So it's going to be 2 minus negative 4, and I have to square that. That's my x's. And then I do the same thing with my y values, 5 minus negative 7, and I have to square that. So that's going to be a distance of 6. So I have 6 squared, and from 5 to negative 7 is going to be 12. 12 squared like that. And so 6 squared is 36, and 12 squared is 144. So that equals the square root of 180, I believe, if I did that right. Which I think I'll just leave like that. There's a perfect square probably that we can pull out of there if we had to, but that's the distance formula. Now, the other one, then the midpoint formula, fairly similar to that. The midpoint formula, I basically add the 2 x values. So this time, 2 plus negative 4, or 2 minus 4, and I divide by 2. And then the same thing with the y values, 5 plus negative 7, or 5 minus 7 divided by 2. So this will give me negative 2 divided by 2, which is negative 1. And negative 2 divided by 2 on the y's as well, so that's negative 1. So there are a couple of old school formulas that probably used before, which might come in handy as we move. Next type of problem is a little goofy. We're trying to determine, if I gave you these 4 points here, do they form a parallelogram? Okay, well, first of all, let's plot these points and just see where they're at. So negative 4, 2 is right about here, and negative 3, negative 2, like that. 3, negative 3 down here, and 1, 5 up here. I'm going to connect these up, and you can tell maybe a little bit by the drawing here that it doesn't look like it's going to be one, does it? But how would I analytically show this, or analytically prove that this was or wasn't a parallelogram? Well, what do we know about a parallelogram? One thing is that the opposite sides are parallel and the same measure, same congruency. So we could figure out the slope of opposite sides, and that would maybe tell us some things right there. Maybe I'm going to label these diagrams here. So this was P, Q, R, and S, like that. So if I could find the slopes here of each of these, that might be good. So the slopes of PQ, and then the side opposite that would be RS. Let's just see if we could do that quickly. So PQ, remember slopes are change in Y over change in X. So for PQ, you have those up there, from 2 to negative 2 is 4, and from negative 3 to negative 4 is 1, so 4 over 1, and it's negative, so I know it's going to be negative 4 over 1. Let's look at R and S. Again, my change in Y is going to be 8, that's from 5 to negative 3, and my change in X from 1 to 3 is 2. Once again, it's negative. So these two actually both equal negative 4 for a slope, so we do know that they are parallel. So PQ and RS are parallel. However, I think you can see that PS and QR are not going to be just looking at our diagram, but let's verify that with our coordinates. So from P to S, looks like my change in Y there will be 3 from 5 to 2. And my change in X from 1 to negative 4 is 5. It's going to be a positive slope like that. And then finally from Q to R, my change in Y will be 1. And my change in X is 6. That looks like that's going to be a negative slope. Clearly these are not equal. So I'm going to say that this for sure is not a parallelogram. And basically, when you find something that is not true, you can stop there. The other thing we could check to see is if these segments or the opposite ones are congruent. And it looks like they're not going to be either. But I can stop basically here as long as I showed that one pair of sides was not parallel. That was enough to disqualify this from being a parallelogram. Here's the tougher one, I think, probably of this unit here. Prove. Now, a lot of times math students get the jitters when they see that word. You might remember your geometry days, and that was sort of difficult. But again, this is a different type of proof, more of an algebraic proof. So we want to prove that the diagonals of a square are perpendicular bisectors of each other. Now, there's some strategy involved here, especially when I draw my little diagram here. The thing is, when you prove something, it does have to be general, but we can help ourselves out with some strategic labeling of stuff. So let's say I have my square here, and notice where I'm putting it. I'm going to put it so one of the vertices here is at 0, 0. And then I'm just going to say another one of my vertices is A0, and we're going to call this A, right? Because a square, all these sides, if we know it's a square, then all these sides are congruent. This one then is going to be 0A. So this is kind of sneaky. We're labeling the coordinates fairly generically with a variable, but because of some judicious labeling, that will probably help us out quite a bit. Now, we want to know something about the diagonals. So again, the diagonals, of course, are those lines on the interior of the square that go in like that. Okay? Now, perpendicular bisectors, that means we better find something about the slope of those. And sometimes it's good to label these sides here. Let's see, so I'm going to just start with this one. I'll make this one A, and this one B, and C, and D like that. So I'd like to look for my slopes first of all. So let's see if I can find my slope of BD, and then my other diagonal is AC. So let's look at that. Now this will be a little tricky because we just have coordinates instead of actual values. But it looks like for BD, my change in Y will be A, right? And my change in X will also be A. So I have A over A. Now it is a negative sloping line, So it is going to be a slope of -1. Meanwhile, from AC, that's the other main diagonal here, if I look at that, again, my change in y is going to be a, my change in x is going to be a, but here I get +1. Now, is this enough to show that these two are perpendicular? Yes, because certainly we usually look for opposite reciprocals, but of course 1 is a reciprocal of itself, and here's my opposite sign right here, so far so good. We've shown the perpendicular part to be true. What about the bisector part? Well, we might want to figure out the midpoint then. I'm going to change colors here a bit and go to this green one. So let's see if we can find the midpoints of each of these segments. You might be able to figure out looking at them that, yeah, I bet I can figure that out. So first of all, from AC, again, I add the x coordinates. So it's going to be a plus 0 divided by 2. And the y coordinates as well. A plus 0 divided by 2. So basically that is going to give me a x and y coordinate of a over 2 and a over 2. Now for BD, I'm going to do the same thing. Just calculate those midpoints. And I think you can see, yeah, I'm basically going to get the same thing, aren't I? My x values are a and 0. My y values are a and 0. And so when I figure that out, I'm going to also get the coordinates a over 2 and a over 2. Now, we've shown then that each of these segments has the same midpoint. They have, right here, we've shown that, and we can see that the diagonals themselves have those negative reciprocal slopes, so we can then make a good conclusion, and here's my 3-dot conclusion then, that the certainly the diagonals of a square here are perpendicular bisectors. And that's what we were trying to show. And so we did it, notice, with some ideas with coordinates, some ideas, some definitions, some basic definitions of slope, and we know what constitutes parallel and perpendicular and stuff like that. So there'll be a couple problems like this that we'll chip away at. And thanks for listening, everybody, and we'll see you in class.